Okay, today we're going to talk about something called transformations, and essentially transformations involve taking one of the 12 parent functions that we have learned in 1.3 and either shifting it right or left, shifting it up or down, reflecting it over the x-axis or over the y, or shrinking it horizontally, like compressing it, or shrinking it or stretching it horizontally, or stretching it vertically, or stretching it or shrinking it vertically. Excuse me. So these are the transformations that we're going to do, and I provided a nice, helpful little transformations cheat sheet for you with the type of transformation, the equation and what the equation should look like, and then whether it's intuitive or counterintuitive, meaning if you want to shift something right, you would think it's right is normally in the plus direction. But when you're shifting right and left, it's actually backwards, x minus 3. And then what operation to do if you're trying to shift it, whether you're substituting or whether you are multiplying. So let's look at a few examples. Let's say we have a parabola. And let's say that we want to, let's just say this is y equals x squared. And let's say we want to do several things with this parabola. Let's say we want to shift it right 2 units. Then if we go to our little cheat sheet, shifting right and left means I need to substitute. There it is right there. You have to substitute in place of this x an x minus however many units you want to shift it. So it's going to be y equals parentheses, because every time we substitute, we use parentheses, x minus 2 squared. Now, very important. Let's say I have y equals 2x squared minus 7x plus 4. And I wanted to take this whole function and shift it left 3 units. Well, that means it's first of all, it's counterintuitive. So it's not going to be left, it's not going to be negative, it's going to be plus, and it's going to be a substitution. So that means I need to take each one of these x's and replace it, actually substitute it for x plus 3. Each one. And if you do that, and you graph this on your calculator, and then you graph this on your calculator, you will see that this is a direct shift of left 3 units. So now we know how to shift things left and right. You just simply substitute x plus or x minus, however many units you want to shift it by. Okay, so let's say we want to shift something up or down. Well, these are the easiest of all transformations. All you do is simply add a constant or subtract a constant after the function. So this is not inside with the x, it is outside, so it's either going to be up or down. And this is intuitive, meaning if you want to move it up, you actually plus something, actually add plus something. If you want to move it down, you actually want to put a negative sign, all right? So there's a couple things that I want you to pay attention to, and I'll put this underneath the this cheat sheet. All vertical movement is going to be outside of the function. And it's going to be intuitive, meaning it is going to be what you think it is. And then all horizontal movement, any horizontal movement is going to be inside the function, and it's going to be counterintuitive. Counterintuitive, meaning it's going to be opposite of what you think it's going to be. Okay, so let's look at another example here. And let's combine them. Let's say I want to, let's say I have a function, f of x is equal to e to the x. No, we'll make it e to the 2x minus 4. And I want to shift that right 4 units, and then I want to shift it down 7 units. All right, if I want to shift something right, that is horizontal movement, which means it needs to be up here with the x inside the function, and it also needs to be counterintuitive. And I go to my cheat sheet, it's going to be a substitution. So everywhere I see an x, I'm going to replace it with x minus 4. Now notice, I didn't just tack on an x minus 4. I used parentheses because this is really going to be 2x minus 8. And then I need to move this thing down 7 units, so I need to actually subtract 7 from this negative 4, and I get negative 11. So my new function, and if you're using a calculator, I want you to actually prove this to yourself so you can see that it has been shifted right 4 and down 7. So e to the 2x minus 8 minus 11. Okay, let's say now we want to work on reflecting something over the x-axis or the y-axis. So let's say that we have the function. Let's say we have the function e to the x. So we'll just say e to the x. We'll start with that. So y equals e to the x. We want to take that and we want to reflect it over the x-axis so that it ends up looking like this blue function here. Well, notice this is vertical movement. So vertical movement is going to be outside the function and it's going to be intuitive. So vertical. So we need to reflect it over the x-axis. This is going to be a multiplication by negative 1. You're going to multiply the entire function. So y equals negative. You're going to multiply the whole function by a negative, which is essentially going to make all the y values the opposite of what they are. So that's going to flip over. Now, let's say that I want to reflect this yellow function across the y-axis so that it now looks like the red function. So I want to flip it over the y-axis. Now this is, notice the direction my pen is going. This is horizontal movement. So therefore, horizontal movement is going to be inside with the x. It's going to be counterintuitive, but it's going to be inside with the x, and it's going to be a substitution of negative x. So I need to go and replace this x with negative x. See, so this is a multiplication. This is a substitution. So let's put a few things together here. Let's say I have the function y equals the absolute value of 2x minus 3. And I want to first shift that left 1 unit. And then I want to reflect it over the x-axis. And then I want to move it down 3 units. All right, so let's see if we can do this. Moving it left 1 unit, I need to replace this x with x plus 1. Then I want to shift it over the x-axis, or reflect it over the x-axis. So I go to my cheat sheet, and that means to multiply the entire function by negative 1. Now, since this is an absolute value, you can't distribute the negative 1 inside, so you just have to leave it outside here. And I'm going to go ahead and distribute this 2 in here. And that's going to give me 2x plus 2 minus 3, which is 2x minus 1. All right, now I need to move it down 3 units. So all I do is tack on a minus 3 on top of after the function. And I want you to graph it for yourself to prove that what we just wrote down is indeed left 1, flipped over the x, and then moved down 3 units. Okay, these next transformations are probably the most difficult ones to memorize, and that is the horizontal shrink and stretch. So the best graph that we can probably use for this would be the sine and cosine graphs. So let's say I have a sine graph. Looks kind of like this. And let's say I would like to shrink this horizontally so that it looks more like this red curve. So let's say it does 2 cycles by the time this does 1 cycle. So I want to shrink it. That's probably not the best drawing, but I want to shrink it half its size. Well, horizontal shrink, you would normally think a shrink, all right, would be making something smaller, all right? So horizontal shrink essentially is what you want to do is you want to actually substitute it with a multiplication, all right? So you want to substitute. So let's say this is y equals sine of x. Then if I want to shrink this twice or half of its size, then what you do is you replace the x with 2x. Now I know what you're thinking. You're thinking, wait a second, I'm multiplying by 2x. Shouldn't that make it bigger? No, because this, my friend, is counterintuitive. It's the opposite of what you think. So if you want to shrink, you actually multiply. If you want to stretch it by twice its size, then you actually multiply by x divided by 2. So these ones are the hard ones to remember, but once you get it down, you'll have them down. Now, horizontal shrink, horizontal stretch, that's what you want to think about. Counterintuitive, they're both substitution steps. Okay, so let's now put it all together here. And let's say that we have the function y equals, let's just say it is the square root of x plus 3, and we'll just leave it there. Let's say we now want to shift this. Let's say we want to, no, you know what? Tell you what, we will first reflect it across the y-axis. Then we'll shift it left 2 units. And then we're going to, let's say we will horizontally stretch by 4. Okay, so reflecting across the y-axis is horizontal movement, so it's going to be a substitution. So it's going to be substituting negative x in place of x. So the first step is going to look like this. Now I want to shift it left 2 units. Well, that is still horizontal movement, so it's still going to be a substitution, and it's going to be counterintuitive. So left 2, negative, I replace the x with x plus 2, plus 3. Now I want to do a horizontal stretch by 4. Horizontal, counterintuitive, substitution, same deal. So we're going to put a negative, parentheses, and we're going to replace only this x with x divided by 4 because it's counterintuitive. Stretch, you think bigger, but it's really divided by. Then plus 2 and plus 3. And that is as far as you can go. The last type of transformation we're going to look at is vertical stretches and shrinks. And so once again, we will take this same sine function. And let's say we have the sine function. And let's say we want to stretch it vertically. So in other words, now we just want to make it go up higher and down lower and up higher and down lower. Well, all we do is because this is vertical movement, then it's going to be intuitive. It's going to be what you think it is. It's going to be also multiplication, not substitution. So if you want to stretch it vertically by 2, hey, multiply by 2 on the outside. So outside, intuitive, vertical, multiplication. Let me add that in there. Horizontal is going to be substitution, inside, counterintuitive. All these are the key words. So if I want to shrink it so that it looks more like the red function, so that it looks more like this, then I need to multiply once again, but by a fraction. So maybe like by 1/4 or something. And then that's going to make it 1/4 of its height. Okay, now let's go backwards and let's see if I give you a function that has transformations in it, are you able to figure out what order the transformations were given or performed, should I say. So let's just start with something like this. Now, I want to give you a process for doing this. Always, number one, always list your right and left movement first. Actually, let me write that a little bit better. Your right and left movement first. First. That is the key. Make sure you do that first. And then after that, follow PEMDAS. Follow the natural order of operations. So, the first thing that should jump out at you all the time is the x minus 2. So that's going to be right 2 units. So as you're listing them in order, it's going to be right 2 units. And then now we follow PEMDAS. So parentheses, meaning do everything inside of the grouping symbol. So we need to take care of this 3x right here. So replacing an x with 3x means that it's counterintuitive. So that's going to be a horizontal shrink. And if it's a shrink, you use a fraction, not a whole number, by 1/3. Okay, parentheses, exponents, multiplication. So you're going to go outside and look at what's being multiplied. And you notice that the whole function is being multiplied by negative. So that's a reflection over the x-axis. And then the last thing is addition and subtraction, plus 4. These are the easiest ones, up 4 units. Let's do one last example here. And let's say I give you y equals the absolute value. Now let's just say negative 1/3, the absolute value of negative x over 2 plus 1 minus 3. Okay, so we got a lot of transformations. I see 1, 2, 3, 4, 5, 6 transformations. So the first thing I'm going to do is I'm going to list my right and left transformation. I see an x plus 1. So I'm going to write that as left 1 unit. And then I'm going to stay inside of my grouping symbols because now I'm going to follow my trusty PEMDAS. And so are there any parentheses? So we're going to do replacing the x with negative x is going to be reflection over the y-axis. Then I have x divided by 2, so therefore that's going to be a horizontal stretch by 2. Now these two, order doesn't matter because essentially they're both with the x here, so you don't have to worry about the order there. But this one has to be first. Now, we're done with everything inside. Now we go outside. Now the 1/3 and the negative is multiplying this function. So once again, because they're both multiplication, the order doesn't matter. So multiplying a function by a negative is a reflection over x-axis. And then multiplying an entire function by a constant of 1/3 is going to be a vertical shrink by 1/3 and then down 3 units. And if you practice this, you will be able to identify all the transformations in whatever problem we give you.